So now we get to the sticky end of things, and it asks us this question. Again, I'll give you the exact wording. It says, examine the behavior of y as x approaches infinity, and hence deduce that it also has two inflections. Okay, so we'll do it one part at a time because there's an easy part and then there's a part. Examine the behavior of x approaches infinity. Let's have a look at this thing, right? There it is, right there, as x approaches infinity. Now, there's two interesting things happen and they collide, right? And this is where our work with further graphing will help us a little bit. 1 plus x all squared. What's it doing as x approaches infinity? It also is approaching infinity. It's just climbing off. It's a parabola, isn't it? 1 plus x all squared, so it's off it's going, right? But, so I'll actually just quickly draw that. So this guy is going up, right? What about e to the negative x? What's that doing? Yeah, it's dropping like a rock. It's going down and it's approaching x equals y equals 0. Okay? Now, when you look at these two and you're taking the product, it's not immediately clear what's going to happen. Like there's this tug of war thing happening, right? Which one is going to win? The 1 plus x. Now, it's kind of funny because if you do the shape of it, like it's, well, like I said, it's not obvious, right? And you might think, okay, well this guy is he's dropping down slower, but it looks like he's slowing down. Yes, it kind of looks like that. That's a little bit deceptive. Okay, here's the way you can know. In fact, it's the exponential that wins. Any exponential, like think about its derivative. Think about its derivative. So, for example, when we said something like. And this is actually in base. Okay? Just think about this guy for a second. Just the regular derivative. By definition, what is he? dx, right? Okay. So when you think about its gradient, its gradient is either going crazy steep, just like this is, right? Or it's dropping really, really fast, right? Because if it's on the denominator, it's doing the same thing. Like this is shrinking at the same speed that this is growing, right? In other words, really, really fast, okay? Whereas when you think about this guy, where is he? There he is, 1 plus x all squared. We in fact already did this when we were doing product rule before. What happens to him? He turns into that, right? Now, you compare those now. Now it becomes a little more obvious, right? Like, yeah, it's going to get smaller. It's going to get bigger. But the rate at which it's doing it is, well, it's slowing down. If I differentiate again, it's slowing down, it's slowing down. And that's what polynomials do. Every time you differentiate, the degree will drop down. But no matter how many times you differentiate an exponential, you'll still get an exponential of some variety, right? So therefore, these guys will always win. Always, every time, okay? So we'll talk a little more about like how there's another result I'm going to show you later today. I'm not sure if it's going to be this lesson or in the afternoon, where we'll do this same kind of process, but a little more rigorously to show you when you're comparing these two kinds of things. Okay? So the rule of thumb to remember is this exponential will always win. In fact, exponentials win in comparison to almost everything, except for these guys, which is why they have that symbol. Anyhow, that's beside the point. You don't need to worry about graphing now.
Wait, can you graph that?
Oh yeah, well, I mean, in principle, when we think about, yes, when you think about, visually thinking about it, if you think about like a parabola versus an exponential versus a factorial, like for us, for our puny human eyes, it's like, well, they just all look like increasing things, right? But if you start to compare the numbers, like, I'll give you an example. I don't know if anyone's seen this this trick before. I don't have one with me. If you have a deck of cards, right? A deck of cards, and you think about how many ways can I arrange this deck of cards, right? It's like, well, what? I'm now thinking about something you're going to meet in term 3, but you guys can work this out. The first card that I pull out, there could be 52 different cards it could be, right? 52 different cards. So that's how many possibilities there are for the first one. When I have a look at the next card down, I've taken one card out of play. There's still 51 left, right? So then that's that. And then for every card down, right, I'll get all the way down to 1. And that will give me the 52 cards in the deck. Now this number, right, like I've only counted to 52, okay? Like someone who was 3 could count to 52. This is not a big number, okay? But this is like, I think this is, man, I know what the I don't know what the number at the front of the scientific notation is, but I'm pretty sure it's 10 to the 67. Is it 67? It is, right? Now this is like
oh, I got 71.
Like this is Really? 52 factorial.
factorial.
Well, it should be bigger though. Yours should be bigger.
Yeah.
67? Oh yeah, sorry, you're at 71.
Yeah, yeah.
Okay. Now, this number is so astronomically large. Like if you can compare it to, if you had 100 people, right, and they were just dealing out decks of cards, like every single second they could deal out a whole deck of cards. The number of seconds that the universe has existed, according to like what we understand of the Big Bang, is 10 to the 18 seconds. 10 to the 18 seconds. If you've got 100 people doing that, you just multiply by 100, that's 10 to the 20. You're still 47 zeros away. So the trick that they say is, if you deal a deck of cards, there's every likelihood that that deck of cards has never ever been dealt in the history of the universe. Because there are just so many decks of cards that can be drawn, right? Now, that's what the factorial function is doing. Like that's the insanity of its growth. Whereas like exponential growth, we experience exponential growth all the time in like populations, like a virus or something like that will grow exponentially, but it's nothing like this. Like this is quite literally it's off the planet. Anyhow, so all of that just to establish this guy wins, right? This guy wins. So remembering that this is shrinking and this is growing, but this shrinking happens more significantly, right? I would say this. This is passing. Limit as x approaches infinity of y, of that function, it's going to approach 0, right? The e to the negative x, it wins, and e to the negative x is going down to 0. Okay, then they say, right, if you know that, it's so understated. If you know that, can you draw a conclusion that there are two inflections?